So compressible flows, of course we are dealing with compressible flows, Mach number greater than 0.3, and we actually go towards higher Mach numbers as well. So the compressibility effects become very important. In particular, the density changes, temperature changes, pressure changes, and so forth. At a point where the Mach number is high enough, we will see the formation of shock waves, okay? And through the shock wave, you will see sudden changes in the properties, okay? But also, you will see changes in the forces and moments, forces being lift and drag, and the moment, typically the pitching moment, which is a result of lift and drag itself. So what I'm going to do after discussing briefly the compressibility is just to show you what type of typical behavior and typical flow physics we might see as we increase the Mach number. And as we do that, try to think about what you guys have done so far in terms of your coursework and whether some of the ideas discussed actually correlate with that. So let me just remind you what we mean by compressibility. So a flow is compressible when the density changes, so it's not constant. And actually, the point of the idea of compressibility comes really from the concept of volume change. So if you start with a fluid element like this, of a given size as shown with an initial volume V, all right, and it's actually acted on by a pressure P uniform, normal in all directions at the start. And the question is, what happens if I increase this pressure P by a small amount delta P? Okay, so you just increase the pressure. We know from experience that we will squash that volume of fluid. Typically, it will go down, say, to a smaller volume like this. And of course, the change in volume here is negative because the volume has shrunk. So compressibility is a measure of how much the change in volume or how much a change in volume as a result of an increase in pressure. And it's actually defined mathematically this way. So compressibility tau, I know we usually use tau for skin friction, but it can be also used for compressibility, is equal to minus 1 over V dV dP. So dV is the change in volume, and delta P is the change in pressure, in this case, increase in pressure. Do you guys remember from last year, why do we have negative in front of the equation? Suleiman, why do we have the negative? Obviously, compressibility is a property. Anyone remember? Why do we have the negative? Very good. Can you be more clear? So delta V is negative, yeah? So what I told you here is, because we went from a big volume to a small volume, delta V is negative. So think about this as delta V is negative, negative becomes positive. So compressibility is just a number, positive number. So that's why we have the minus there. Anyway, but then we always talk about compressible flows being related to density changes. So clearly, instead of using this kind of initial concept of relating things to volume changes, we can also relate it to density change. So if you rewrite it slightly, you will get that compressibility is 1 over rho, the change in rho by the change in pressure. Okay? So quick question for you guys. If you compress something, what happened to the density? Does it increase or decrease? Increase, very good. So the change d rho here is clearly positive. Therefore, we don't need the minus sign that we had with the volume. So that's why it doesn't have a minus sign. So really, one way of expressing compressibility, which is really change in volume or change in density as a result of change in pressure, is to write the compressibility itself, or probably more practically, to think about density changes as delta rho equal compressibility of the fluid. Each fluid has a compressibility. For example, if I remember top of my head, the air is 15,000 times more compressible than water. So water is very hard to compress. This is why we don't have those water cylinders, right? We only have gas cylinders. And because gases are very easy to compress, we can actually squash them in the volumes. That's why we have those cylinders. Anyway, so that gives you a change in density as a result of the change in pressure, and tau is the compressibility of the fluid. Rho here is actually the initial density of the air, or the gas we're talking about. So this is kind of, it makes sense to relate all these qualities together.